This is lecture 8, part 1. And in this lecture, we will not introduce any new topics. We'll just continue from the last lecture on the topic of computer vision. And actually, in part 1, I will not introduce any new algorithms. So if you want to skip it, it's okay. I'll just repeat basically what I said in the last part of the previous lecture. So in the last lecture, we talked about two computer vision features, SIFT and HOG. So they are used to replace those pixel intensity features, which are not good, which they do not capture the information about the region in an image. But SIFT and HOG features, they do capture some information about the region instead of just that pixel. So let me show you the same image that I showed you last time. So for SIFT, what we are doing is basically we find the key points, some of the important special points in the image that we want to find an object of, and we find the key points for the image of the object as well. And then for each one of those key points, we compute this 128 dimensional feature that represent some information about the region that point is in. And then we do the same thing here in the other image. And know that if they have the same shape, if they represent the same object, then these key points should be the same. And also these features should be very similar. So what you do next is you would just match these features, and then hopefully you will be able to find where this object is in the first image. So that's the basic idea behind SIFT. And for HOG, it's actually what we want. So let me show you that image, that one. So we have an image, and then for each small region, so for the first region, second region, for all of them sequentially, systematically, we're going to compute these HOG features. And HOG features basically nine numbers or 9-dimensional feature for each small region, representing the magnitude of the gradient in these 9 directions in this region. And if we do this, if we repeat this for all the regions on this image, then we can combine them, the first 9, second 9, and so on. And then that would be our vector x. And that's actually the x that we are familiar with, that we use neural network, we use support vector machine and so on these. And we have some of the images that are labeled, like we have this image labeled as a person, and we have some other image like this is labeled as not a person. Then we have these training set x and y pairs. We can train a function like this. And then if we are given a new image, we can do the same thing, actually find the HOG features of this new image and actually apply the same function to predict what this picture is. There are a few problems with this. So first, we cannot find object within this image. So for example, we want to figure out where the face is. It's a small region in the image, it's not the whole image. So it's kind of not clear what kind of X we should use. So the other problem is it's still very slow. So we want something that's even faster so that we can do real-time face detection. So we want this to be even faster than HOG. And we also want basically the matching capability of SIFT. So we need to come up with something else. And in fact, when we are actually doing real-time face detection, there are many locations at different scale. However, there are only a few faces. So there are a huge amount of regions that are not faces that we want to reject them very quickly. We don't want to to spend a lot of time on the places where there are obviously not faces. So we have these problems. And in the next part, I will basically introduce another feature called the hard feature, which is really, really fast to compute, and then an algorithm called Viola Jones to use these features to figure out where a face is in an image.